Hi, Michael. Thank you so much for joining me.
Well, hi, it's my pleasure.
Okay, so Michael, tell me what you're seeing in terms of trends in the power market.
Well, what we see is a dramatic increase in the need for more computing power in lots of end markets, including the military, the rail markets, automobiles, aircraft, and industrial machinery. Inside these end markets, we see applications that include engine and braking management systems. We see passive and active safety systems, guidance systems, and the all-important Wi-Fi. Everybody wants Wi-Fi in their car, they want them in their plane, they want them in their train. And all of this extra computing power means more power delivery.
So, how does Vicor expect to address this need for more power?
In a few words, it's an increase in power density or more power in a smaller package. These applications require a lot of power, and the space allotted is very small.
So, Michael, why an increase in power density rather than just an increase in power output?
Well, the power need has increased dramatically, but the area allowed for this power delivery has stayed the same. If you take a look at planes and trains and automobiles, the vessels are the same size or even smaller, but the power requirements are higher. So there's a lot of competition for this space, and we can't have the power product be the majority user of that space.
Okay, cool. Can you tell me more about how Vicor is helping to solve the increasing need for more power in the same or smaller space?
Vicor predicted the increase in power density need many, many years ago, and in our new generations of products, we've increased the power density dramatically. This slide represents 3 generations of DC to DC converters at Vicor. On the left-hand side of the x-axis is our first generation brick-type products, the VI100 and VIJ100 products. The second generation, also a brick-style product, is the Maxi, Mini, and Micro products. These products do range from 100 to 500 watts, so they are high-power products. But as you can see, the power density, what we call watts per cubic inch, is relatively low at less than 200 watts per cubic inch. If you go further down the x-axis, you see our DCM2308 products at roughly 300 watts per cubic inch, our DCM2322 at 500 watts per cubic inch, and we'll be talking about that product a lot more later. We have the DCM3623 at roughly 800 watts per cubic inch. We'll also be discussing that product later. And then to cap it off, we have the DCM4623 series products at well over 1200 watts per cubic inch. So how we created this increase in power density is we've developed IC-based controllers. And what these controllers are is they're an integration of active and passive components, parts that would have been on the PC board, discrete units on the PC board, and we've integrated those into a piece of silicon. What that does is it allows us to control line impedances, it allows us to control the proximity of the devices, and it shrinks the area needed in order to produce the same amount of power. The second way we did that is we've developed these, what we call a proprietary power packaging. And these packages are designed specifically to accept these controllers, have less active components, and together we create very, very dense power products. As an illustration of power density at Vicor, we have superimposed on top of a traditional half-brick 300-watt Vicor product 2 DCM3623s, each of which are 240 watts. So for 2/3 of the area of a traditional half-brick, we can deliver almost 2x the power of the traditional brick product. So that's more power in the same or smaller space.
All right, so Michael, can you describe more about Vicor's proprietary power dense packaging?
On the left-hand side of this slide is a traditional silicon semiconductor wafer. Imprinted on this wafer are many ICs. Once the wafer processing has been completed, the wafer is sawn and diced, packaged, and tested. And this is very analogous to Vicor's chip panel process. In the chip panel process, the panel is inserted into the front end of a very long, contiguous manufacturing operation. The components are then mounted by state-of-the-art, computer-controlled pick-and-place system. Once the chips are finished assembly, they are singulated, tested, and shipped to a customer.
So with the focus on power density innovation in IC-based controllers and that unique power dense packaging, it seems like Vicor is really creating value for its customers.
Yes, we know that density is key to supplying the increase in computing power. However, there are many other aspects that are just as important. Take efficiency, which is really just a measure of how much power is retained after the conversion process. The higher the efficiency, the easier it is for the customer to cool and the less power loss. In conjunction with that, these new power dense packages have much lower thermal impedances, so they're easier to cool, they're easier to interface to. So you have less heat loss, you have easier packages to cool, we have top and bottom side heat sinks and heat spreaders, and we have the reliability as discussed in the manufacturing process. What we really think is important to customers is the density cost equation. Because this is a very high density product, because we have easier cooling methodology, and because this is easier for the customer to use and uses less space, we believe that the cost benefit of this product is much greater than some of our older generation brick products.
Okay, let's talk about Vicor specifically in the rail market.
As we've seen in a lot of the rail market, there are many applications. We have applications in drivetrain, including braking systems, engine management control, climate control. We have safety applications in security cameras, in intelligent door activation, and information displays. We have platform applications, including ticket machines and displays on what times and what tracks your trains are on. And of course, the most important thing for anybody who's traveled on the train for any length of time, Wi-Fi. There are lots of Wi-Fi repeaters in a train, and we have to power every one of them. Again, the trains need more power, but the train size has not changed. So with this added power, with this added need, we have to be able to supply the power to these electronics and do it so in a space-saving manner. Vicor has been in this business a long time, in the rail business, and we continue to support this business. We've created a reputation for innovation and quality in the rail industry. Rail products are in very demanding environments. If you can imagine that 1 minute a train is in a valley and 2 hours later it's on top of a mountain. That's a 50 to 60 degree Fahrenheit change in temperature. We have rail environments where these products are in trains that are 95 degrees Fahrenheit and 95% humidity for 6 months a year. The shock and vibration that these products see are immense. I mean, they travel on train tracks everywhere. They are tilting all over the place. So they get abused a lot. And because they are, we have to make sure that that's incorporated in our design process when we develop these products. Another aspect of this is that we understand all of the country rail standards. Each region, each country have their own standards for EMI, shock and vibration, voltage ranges, and we have to understand that from day one and build that into the product. The other aspect that's very important to us is maintaining and improving quality and reliability. Let's face it, there are people on these trains, right? And we have to make sure that the trains aren't stopping 10 miles from the station and having people walk. It's just very important that these trains are very reliable. So I think what rail customers should view Vicor is, we have this as a major market focus. We have products specifically for this market. We know the power levels. We have the correct input voltages, the correct output voltages. And the most important is our management team sees this as a major focus and provides those design resources for products for this market.
Okay, Michael, so what are some of Vicor's products that are made specifically for the rail market?
Sure. The first one is the DCM3623. It's for higher power rail applications. It is an isolated, regulated DC to DC converter. It's roughly 1.5 inches long by 1 inch wide. It covers 3 of the most important rail voltages. It has a power density greater than 800 watts per cubic inch. Peak efficiency is up to 93.6%. And like all Vicor DCMs, it can be arrayed for higher power outputs. This page represents the DCM3623 table. As you can see, there are 6 input voltage ranges, anywhere from 9 to 50 volts to the most important rail input voltage range of 43 to 154 volts in, or 110 volts nominal. We have output voltages from 3.3 volts to 48 volts. We have power output capability between 80 watts at the lower output voltage levels, all the way up to 320 watts at the higher output voltage levels. Next is the DCM2322. This is our ultra compact DC to DC for rail. This is also an isolated, regulated DC to DC converter. It is less than 1 inch on the side. It has all 3 of the input voltage levels required by the EN 50155 standards. It's up to 90.5% peak efficiency. It has greater than 500 watts per cubic inch in power density. And again, just like the 3623, it can be arrayed with up to 8 units with no power derating. It's the smallest, widest input range, highest efficiency, and highest power density product on the market. This is the table of its input voltage range and output voltage range. As you can see, the three EN50155 input voltage ranges are listed here: 9 to 50 volts or 30 volts input nominal, 14 to 72 volts in or 43 volts nominal, and 43 to 154 volts in or 110 volts nominal. We have the same output voltage range as the DCM3623 at 3.3 volts to 48 volts. And we have a power output range of between 35 watts for the lower output voltage range, all the way up to 120 watts at the higher output voltage.
Design support is very important in power conversion. So, Michael, can you describe what Vicor is doing to help power designers improve time to market?
Vicor prides itself in bringing the whole product to market, and that's just not jargon. We really do believe that our goal is to provide resources to reduce customers' time to market. The first thing I'd like to talk about is this DCM2322 evaluation board. You can get this board in any of the input voltage ranges and any of the output voltage ranges. You can use this board as is, just as you can see, plug in your inputs on the left and get your outputs on the right. You can also take this design, we'll give you the schematic and the Gerber plots, and put it right down in your design. You can remove the things you don't want, you can add things you want, but we'll actually give you the schematic and the Gerber plots to use as is. The second slide here is an EMI filter reference design for the 2322. It meets the EN50155 standard for EMI and EMC. And as you can see, it's very simple. It's around 20 components, most of which are capacitors. There's a couple of inductors, and we provide this free of charge to all of our customers. You can put it down as is on your design. It meets all the EMI standards for rail products. And again, it's very, very simple. In addition, we have other design tools. We have behavioral simulation models for people who want to simulate their environment. We have 3D models of the packaging, so you can drop those into your PCB design libraries and use that in your circuit development. We have heat sinks and heat spreaders. We have a DC trim calculator that allows you to dial in the output voltage to the perfect output voltage you need for your application. We have application notes specific to the rail industry on EMI and EMC. We have mounting and reflow specifications to help you assemble this product into your design. We have a new thermal tool that allows a customer to pick their cooling methodology, be it a heat sink or a cold plate. You add some other cooling parameters like what is your linear airflow per minute, what's your output voltage range, what power you require. And this tool will come back and tell you exactly what you need to do to cool the part in order to achieve the power output you require. Our goal is to have our customers have a working design in as short a time as possible. And we've put a lot of time and effort into bringing the whole product to market.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Michael. It was a pleasure speaking with you.
No, you're very welcome. Thank you.